All right. Hello, Twitch. Okay, so before I get started, just so that I know what to focus more and less on, what brings you guys to lecture? Raise your hand if you want to learn more about Java as a language. All right, what about collaboration with Git and GitHub and stuff like that? Okay, what about just seeing development of a bot in real time as sort of a way to learn how to do Battlecode? All right, cool. All right, I guess I'll focus on Java and developing then. And let's see who's here. Shayna,
hello.
You're watching Twitch for questions? Okay, great, thanks. Okay, let's get started. So last time we left off with miners which move around randomly, find some soup, and then bring it back to the HQ. So that was great, but all we did with that soup was just make more miners, which is not the most useful thing we could possibly do. Oh, sorry, also a couple of announcements. There's a big new version coming out tonight, probably during lecture, but I'm not exactly sure when, with a few clarifications in the spec, including rules that we have for maps. So maps are always going to be 32 by 32 to 64 by 64. The HQ will always be at an effective elevation between 2 and 5, which means either the HQ will be at an elevation between 2 and 5, or if it's lower, there will be some sort of natural barrier at elevation 2 to 5 between it and the water. So the HQ, if you do nothing, will always flood when the water level reaches between 2 and 5. We're also always going to have at least one water tile with a very negative elevation so that you can't fill it in and cause a game to never end. Sorry. And we'll never start the HQ adjacent to a deep water tile. So, in which case you wouldn't be able to defend your HQ from water level rise. There are also some improvements to the client, including a better sort of gradient so that you can see differences in elevation better. Some various bug fixes you can't see it because that might be a problem later, but there are a couple of typos in the client. And then various engine bug fixes. For example, I think when you placed a unit with a drone, it would just get destroyed, which is not what you want, and stuff like that. Okay. Oh, also, I owe you from last time the solution to that 100 problem. Minor /dot. Yes, okay, so the thing where I gave up and put 100 last time, I had a typo, which was like this, and that's wrong. It's just soup limit, but this acts as expected. This gets the soup carrying limit for robot type miner. Yeah, okay, so let's get started, and let's start by making something that aren't miners. So the HQ is the one that the only thing that controls the production of miners. So let's just make it only build 10 miners. So if we wanted to do something like that, we can just add another variable up here, static int num miners, and then have the HQ check it in run HQ. Nope, that's not right. Run HQ. So right now, all it does is build a miner, but instead, let's have it count the number of miners. So try build, I believe, is going to return true if it succeeds in building the robot and false otherwise. So what we can do is just add an if statement right here. So we can say if try build succeeds, then we're going to do num miners plus plus, which is something that you can do in Java but not Python. This is equivalent to num miners plus equals 1, except that it returns a value. So you can do things such as in a for loop, if you wanted to do, just as an example, so for int I, so this is creating a new integer, starting at 0. If you wanted to be fancy, we could start at 10 and go backwards. So we'll go from I minus minus is greater than 0. And then, so usually the way we would do this is we'd say I greater than 0, and then I minus minus to decrease it, right? And then we would do whatever. And so what this is going to do is it'll start I at 10, it'll check if it's greater than 0, and if so, it'll do the loop, and then at the end of the loop, it does I minus minus. So this first part only happens at the beginning, the very first time. The middle part is what decides whether the loop runs or not, and then the last part happens at the end of every loop. So this is equivalent to not having anything right here, and doing all of our stuff, and then doing I minus minus, or I minus equals 1. You shouldn't edit for loop variables inside the for loop themselves. If you wanted to do that, you would have like a while loop, but it's equivalent to doing that. So we can put our I minus minus back here. Oops, I minus minus. But what's cool, and what you'll see sometimes, is that since I minus minus both decrements I and returns the new value, some people will say if I minus minus is greater than or equal to 0, then and this should be equivalent. So let's add a system.out.println just to confirm. So we'll print I system.out.println testing for double quotes. Testing for loops. Also, you need double quotes in Java. Sorry. So if we do this and then we run the lecture player, just to confirm, we can see in the logs. Oh, right. Run game. Was there another error? No. Okay. Okay, so we can see the logs here that I had it backwards. I minus minus is going to return the initial value. So if you wanted, okay, yeah, sorry. So if you have, so 10 plus plus returns 10, and if you want to add first and then return, you do plus plus 10, and that returns 11. So the for loop that we had before, where we don't want I to go below 0, would be this. So we subtract it, and if the thing before we subtracted it is greater than 0, then we'll continue. So this is going to go from 10 to 0, or from 9 to 0, I mean, because this check happens at the beginning every time. So to reiterate, it'll start at this, it'll start at 10, and then it'll subtract 1 from I and check if if the previous thing was greater than 0, and then it'll do our for loop. So this is equivalent to if we had started at 9 and done I minus equals 1, like this. These are equivalent for loops. Anyways, that was a long way of saying that Java has this plus plus and minus minus operator, which is kind of cool, and I'm using it right here. So that's all about that. So all right, so now we've got the number of minors. Anyways, we've got the number of minors. So now we can put in a check here. If num minors is less than, maybe we only want to build 10, then we can do this thing where we try to build one in every direction. And then otherwise the HQ will just do nothing, and we'll start saving up soup. So let's just see that happen before we continue. Oh man, there are too many. Okay. So if we run it again, it should only build 10 minors this time, and then just generate a bunch of soup. Unless there's an error. Okay, there we go. Okay, so it's building miners, producing pollution and stuff, and we have exactly 10 miners. And the soup is just building up. So great, that's what we wanted. Now we can spend all that soup on something else. Since this is a logical stopping point, or like a logical breakpoint, we're gonna make a commit. So we'll go back to where we were. We'll say get status to see what's going on, and then we can do get diff to see what we changed. So we added this num minors thing. Okay, great. So now let's get commit am count number count num minors. Okay, great. So now let's continue making some changes, and we'll go back over to this once it's being done being slow. Okay. All right, so now we want the miners to build a design school, which is what's going to make landscapers. So we can just throw that in the miner function here. It's probably less important than bringing soup to and from the HQ. So let's put it in, we'll put it in this clause instead. So instead of else if, we'll just make this one else, and then we can take this try move, or you know what, we'll keep it, put it back how it was, and we'll just add a new clause here in front. So we can say else if, and then we'll try build a robot in a random direction. So where was I? Okay. So we can try to build, oh, that's not what I wanted. Try to build we don't want a delivery drone, but we do want a design school. And we can choose a random direction. So random direction. And if that succeeds, then we'll just print .out.println created a design school. Okay, so let's see if that works. And we'll run a new game. What we should see is that after it builds 10 miners, then since miners are cheaper than design schools, the HQ will always win the race to build something because it'll be able to build. It always tries to build a miner, and it'll be able to build because the soup will be lower until we stop building miners, and then we'll get up to the full cost of a design school. Which what is the full cost of a design school, anyways? It's down here. Oh, there it was. Right, so 150 for a design school. So great. Let's see how that game's going. Build 10, or not till miners yet. Okay, looks like we're up to 10 miners now. And then, oh great, design schools all over the place. Fantastic. Okay, so now we have to write the code that controls the design schools. So we're creating design schools, and now what are they going to do? Design school. So far, nothing. But we'll fill it in. So it's going to be similar to the HQ probably. We just want to try to build something in a random direction. So we'll start with, let's not even bother counting up the number of landscapers yet. And we'll do a landscaper here. Okay, so now the design school on its turn is going to try to build a landscaper in every direction. So let's see if that works. If my computer speeds up. Okay. So one thing that may be a problem, whoops. Stop that. Okay, fine. Is one of my keys jammed? Yes. Oh, one of my keys is jammed. That's bad. Weird. Okay. Oh wait, no, that's not what we wanted. Oh, okay, sorry. My tab key got stuck somehow. But that's fine. We'll just make the client again. Okay. And we'll run lecture player. Anyways, so one problem that you may foresee is that design schools and landscapers actually cost the same amount. So we're going to have a problem where the miner, since it goes first on the turn, is always going to win. Sorry, if there's nothing inside this if statement, that's why it was sad. Made a landscaper. So the miner is always, the miner is always going to win the race to build a unit once the soup exceeds 150, and we'll just keep making design schools over and over again, even if we already have plenty, and this is a problem because we really want those design schools to make things instead of just sitting there losing the soup race every single time. So let's just see that happen to confirm. Yep, lots of design schools and no landscapers. Okay, so how can we fix this problem? We need some way to see if there's already been a design school made or something like that. So instead of the miner just building a design school every time, let's have it check the nearby robots for design school. And if there's already a design school nearby, then we don't need one. And if there isn't, then we probably need to make one. So we can go in here, and instead of just always trying to build one, we can say, we'll take this out, and then we'll say, we'll make a new function called nearby building, and we want to check for design school, and we want to say if there's no nearby building, then if this if statement succeeds. So if there's no nearby building, then we'll try to build one in a random direction, and in that case we'll print out that we created a design school. So now we need to write this nearby building function. And I made it more general on purpose because we're probably going to want to use this for other, well, we can call it nearby unit or nearby robot. It's because we're going to probably want to use it for other things. So for example, like if we want to check if there's a nearby enemy drone or something like that, then we would use this function. So let's just make that down here with all our other helper functions. How about right here? Okay, so we'll make static, and then this is going to return a Boolean, true or false, nearby robot, and then it takes a robot type. So again, because it's Java, you have to declare the type of everything that you're using. This is the type of the argument. We'll call it target. And then we need to say throws game action exception. Because if you don't do that, then we have to handle the exceptions here, and we don't want to have to think about that. So we'll just, any exceptions that happen here, we'll just throw them up to the parent function and let that deal with it. And since all of our functions do that, it'll just be caught at this big try catch up here, right here around the run minor function. That's all the exceptions will end up getting caught there. So great. Okay, so we need our what do we call it? Nearby robots, or nearby robot. And okay, here we go. So nearby robot. So first we need to get the list of robot infos that are nearby. So robots equals rc.sense nearby robots. And this will, again, sense all of the robots within our vision radius. So that's great. And now we can just loop through all of these robots. Robot info, R in robots. And so this is the other kind of for loop where we put a list on this side of the colon and the element of each element of the list on the other side. Okay, so for each of these, we'll say if r dot get type is equal to the target type, then we can return true. Oh, I should put curly braces around that. Return true, and then otherwise we'll return false at the very end if we don't find any. Okay, so now this nearby robot function should work, and let's see if that's reflected in the game. So we'll run another game. And while I'm waiting for this to run, does anyone have any questions about anything I've done so far or anything else? All right. All right, so let's see. Let's just jump ahead a bit, and we have to build those 10 miners first. They're not being very intelligent, so we'll have to fix that later. But all right, great. So now the design schools, there aren't as many, and they're getting spaced far apart because now the miners only build them if they can't see anything. And look, we have some landscapers. Perfect. Okay, so now that we have landscapers, we should probably write some code to tell them what to do. Let's get to it. But since again we're at a logical stopping point, let's just make a nice little commit, and we'll check the status. Okay, what have we changed? This is hard to read, but we're just adding a clause for if there are no nearby robots, then the miner will build a design school. And then again, in the last case, if it has nothing else to do, it'll just move in a random direction. But we've done a bad job, because now our if statement is this one is always going to be true. This is why the miners weren't moving in the beginning, is because there were no design schools. And so this was always returning true, but then this build design school failed because there wasn't enough soup, and it never tried to move. So we actually need to make this a little bit more intelligent, and what we can do is, instead of making this an else if, what we'll do is we'll say if refining didn't happen and if mining didn't happen, then we'll still have cooldown to spare. So in that case, we'll make our design school. So I'm going to cut this and put it here. So first we try to refine. If there are no opportunities to refine, even if there are opportunities to refine, we'll still try to mine in every direction, which is kind of dumb, but that's okay, because there won't be any cooldown to spare anyways. And then, regardless of how that goes, we'll check and try to build a design school if there are no design schools nearby. And of course, that will fail if our cooldown is too high. And then in the very last case, if we can't, in the very last case, we'll try to move somewhere. And if there's no cooldown left, then we won't be able to move anyways. But if there is, then we'll do the movement that we coded before, where we check if we're at the soup limit and try to move towards the HQ, and otherwise we move randomly. So already, just from the little stuff that we've written, our code has gotten to be a little bit unclear and in need of refactoring. So there's a refactor in our future, but for now, we're just fervently adding features. So we'll plow on ahead despite the technical debt that's accumulating. And run another game. So now, with that logical error fixed, we should see the miners moving around randomly, and the design schools still being spaced far apart. Okay, yep, they're moving around randomly, great. And they've found some soup, so that's good. And I think we're at 10 now. Oh, one of them died, but what can you do? Okay, and we've got our design schools, great. And the design schools are already building landscapers, fantastic, except they got flooded, but that's okay. Okay, great. So now we're at a logical stopping point and our code actually works. So what we're going to do is now we'll get diff again just to make sure. Okay, great. So we have this clause for building the design school. We've added this new function for design schools to make landscapers. And we've added this nearby robot helper that we used up above. Okay, great. So now we can git commit and add everything, and we'll say make design schools and landscapers. Okay, great. So now let's pull and see if anyone else has pushed anything on our team. The answer is no, it's up to date. So we'll push our changes so that anyone else working on this can have the most recent version. And then we'll do one last thing before we move into talking about Git some more, and that is going to be to make the landscapers do something vaguely intelligent. So the first most important thing for the landscapers to do is probably to defend the HQ, right? So how can we get landscapers to defend the HQ? We probably want to build a wall around the HQ, which will interfere with miners' ability to bring soup if the wall is too high to be passable. But if that becomes a problem, we can always make the miners create evaporators. So let's just try it and see what happens. So what we want to do is we want to make the landscapers go to the HQ and build up dirt in all of the tiles around it. So first things first, landscapers are not useful unless they have any dirt. So let's just check for that first. So if the landscaper doesn't have any dirt, so rc.getDirt carrying, I think is the function. We should check with this, with the docs, just to be sure. Robot controller, get dirt carrying. Great, okay. So if get dirt carrying is equal to 0, then let's just dig some dirt in a random direction, just to start. So is there a try dig function? No. All right. We'll have to write one ourselves. Great. So the digging function is dig dirt and can dig dirt. So let's just see if it's used yet. No. Okay, good. All right, so down with our try to move function, let's just make a static Boolean try dig. And this also has to throw a game action exception because we don't want to deal with those in this function. And then we'll go ahead and say, we'll pick a random direction. Well, we could do something more intelligent right now, because if we pick a random direction, we might dig down our own walls, which would be silly. But let's just try it for now, and we'll add something more intelligent later. So equals random direction, and then if rc.canDig in this direction, we will it's can dig dirt, right? Yes. Can dig dirt in the direction. Okay, and then we'll return true if it's exceeded and false otherwise. Okay, so now we have our try dig function, and we can go back up to run landscaper and say, okay, so if the dirt carrying is empty, then we'll try dig. Okay, and now that that's taken care of, the other important thing to check is if we are near enough to the HQ to deposit some dirt on the wall. So for this, we need to know where the HQ is. And fortunately, we already have something written for the miners to find the HQ location. So we can just take this and extend it to its own function. So we'll take it out of here, and since we want pretty much every robot to check if they can find the HQ, we might as well do it up here. So if I paste this here, well, actually, we should put it in a function if we want to have good style. So we'll put it in a function, and the function will be called find HQ. And since we want all robots to know where the HQ is, we can put it outside that loop. So now every robot, no robot specific function has to worry about it, because every turn it'll just try to find the HQ if it doesn't already know where it is. And since this is used everywhere, I'm going to put it up here, and we'll say static void find HQ. throws game action exception. And then we can just paste in what we had before. So if HQ lock is equal to null, then we go through all of our nearby robots and try to find it. One of the other reasons to put this in a function is that eventually, so not everything now spawns close enough to the HQ to be able to see it necessarily on its first turn. So some robots are just going to be wandering around with no idea where the HQ is. So eventually what we're going to want to do is we're going to want to communicate our HQ location somehow. So that no matter where a robot gets spawned, it can just check the blockchain, read out the HQ location, and then sort of orient itself around that. When we want to do that, all we'll have to do is edit this function. So say like if searching through nearby robots fails, then to do later use blockchain to broadcast location. Or like to use blockchain to communicate. So we can add that in later, and then all of the units will just do that because we're calling this find HQ function in the right place. So great. All right, so now everything should have the HQ if it's close enough, and if not, HQ lock will still be null. So let's check for that here. So if the HQ lock does not equal null, which means we don't know where the HQ is, then we can try to put some dirt around it. So we're going to want to look at the 8 tiles around the HQ. So we'll loop through the directions and add that to the HQ location to check the 4 tiles. So I'll say that again because I said it badly. So what we want to do is if we know where the HQ is, then we're going to check every single tile around the HQ and see if we can place any dirt there. And if so, then great, we've just improved the wall. And if not, then we'll have to move closer or something. And while we're at it, we might as well check which tile has the lowest dirt so that we're making a meaningful contribution to the wall. All right, so that's going to be a lot. Let's loop through the directions first. So for direction dir in directions. So we'll make a map location of tile to check. Tile to check is going to be the HQ lock dot add dir. So dot add is a nice little function that we provide so that you can take a map location, add a direction, and get back a new map location, which is the first location plus the direction. So what this will do is it'll loop through all the directions around the HQ and try adding that direction to the HQ to get each of those 8 tiles. If that's unclear, I should say something now so that I clarify. Okay. Okay, so this is the tile we're going to check. And what do we need to check? We need to check if we can put dirt on it, and we need to check if it's the lowest. So the first thing is can we put dirt on it? So there are a couple of things that we need to check. One is if it's close enough. So if so landscapers can only put things close to them or in an adjacent tile or underneath them. So if rc.getLocation is the location of this landscaper, dot distance to, which is another function that we provide, and I can show you where that is because I also need to remember if it returns square distance or not. So map location, we have add, which is the function I just talked about, and the function distance squared to. So this will tell you the distance squared between two map locations. And that's the one we want to use. So distance squared to the tile to check. So this is going to return the distance between those two things. And if it's less than 4, which is the greatest distance that's not adjacent. And to prove this to you, I'll show you a nice new thing that someone made for squared distances. Battlecode 20. Go away. Battlecode 20. Alright, we'll just navigate to here. So the new version of the specs hasn't been deployed yet, but it is in the GitHub repo. So I can show you the cool distance squared graphic that one of the other competitors made, if it ever loads. But sorry, streaming and everyone being in this room together is slowing things down a bit. But here we go. So specs.md. Okay. Distance squared is up here. Okay, great. So we have this nice little map here. Okay, this is the distance squared from, if you're at the center, this is the distance squared of every map tile around you. And well, let's move this up a little bit. Okay. So the ones that we're interested in are the adjacent ones. So distance squared of 1 and 2. There are no tiles with distance squared 3, which is why I can safely use less than 4 to denote an adjacent tile. So great. Let's go back to that. Also, this version of the spec will be deployed like sometime tonight. Basically, whenever they finish the ranked scrimmage stuff, it'll all get deployed out in one big wave. But anyways, okay. So if we're close enough, and now we need to check if we can even deposit dirt there. So let's find the function for that, and it should be something else named dirt. Deposit dirt. Is there a can deposit dirt? Deposit dirt. Yes. Okay, great. So now we just need to check if we can deposit dirt on that tile. And I'm going to put this on a new line because it's really long. So rc.can deposit, nope, dirt. But okay, wait, so we have a map location here. Tile to check is a map location, and can deposit dirt needs a direction. This is okay. We can just say our direction, rc.getLocation, .direction2, which is another handy function, the tile to check. And since we've now confirmed that it's adjacent, direction2 is going to be exactly correct. If we were farther away, then direction 2 might not be putting us in the right place. But since we're close enough, this is what we want. I'm gonna make it a new, or no, that's fine. Okay, great. So now we're checking if the distance squared is less than 4, and if we can deposit dirt on that tile. Another interesting thing to note about Java is that, similar to Python, it will short circuit if statements, meaning if this first half is false, then it doesn't even bother evaluating the second half, which is great because it saves computation. But if the first half is true, then because this is an and, of course, you need to check the second half to know whether the whole thing is true. If it were an or, which is like this, so that's an or, then if the first half were true, then it would short circuit and not bother checking the second half, because true or literally anything is going to be true, so there's no point. But anyways, yeah, fun facts about Java. Okay, so now I'm going to indent this once more so that it's clearer. So if we can deposit, then let's go ahead and do that. So deposit dirt. rc.deposit dirt in this same direction that we just checked. Great. Okay, so now if they're close enough to the HQ, they should be depositing dirt. And otherwise, we probably just want them to move randomly. So we can just say, we can just copy the same thing that we had from the miners, and if all else fails, if there was nothing useful to do during the turn, so there's still cooldown left, then we'll just try to move in a random direction, and see how that goes. Okay, so that was quite a bit. Let's add a print statement here so we can confirm for sure when this happens, and we'll say system.out.println building a wall. Okay, so let's see how that goes. Okay, while this game is running, what kind of stuff have you guys been struggling with the most while trying to develop bots? Just to like help me direct future lectures and stuff like that. We're planning to have a lecture entirely about debugging in the next couple days, like tomorrow or the day after, because we have a lot of like really helpful tools like indicator lines and stuff like that. But yeah, do you guys have any suggestions for us about what would be most useful to talk about to help you develop faster? Yes. Pathfinding. It's funny you should mention that. It's planned for later today, or sort of basic pathfinding. Okay. Anything else? All right, I'll just keep going then. Okay, so let's see how that went. And if we get any landscapers. Oh, there's a new version. This is the release that I was talking about. Apparently it happened. Oh, great. Yes, we'll talk about pathfinding. Okay. Wow, look at that. All right, so this landscaper right here has been dutifully adding dirt to this tile, which we can see is now at an elevation of 20 instead of 3, which is where it started. So that's fantastic. Of course, this is not a very good wall, but and the water has flooded from the places that the landscaper was taking dirt, so that's cool too. Amazing. Yeah, so there's like negative elevation over here. That's cool. Okay, so that's working well. Water can flow diagonally, yes. Let's see how it turns out. I'm guessing the wall doesn't really help much, and the HQ is going to flood at the same time, as always. Oh, this landscaper has trapped himself in. That's nice. But despite being trapped, dutifully adding dirt to this tile, built it all the way up to 61 before perishing, sadly. Okay, so this has illustrated a couple of things that we need to fix. One is that we forgot to do the thing where we add dirt to the lowest elevation place, and the other is that apparently just adding dirt to the tile or two that the landscaper can see is not sufficient to build a good wall, and also may cause the landscaper to perish. Let's start with the lowest elevation improvement first, but this message here has given me a great excuse to show you what you should do when you see a message like that. And the answer is you can do this through your IDE also, like Eclipse or IntelliJ or whatever. If you're doing it from the command line, it's just /gradlew update, and I can show you what the output looks like. So that will make sure that everything is up to date, and then you can say build, and that will automatically download the newest version. And we should actually, when I run the client again, we should actually see better shading and stuff. So that'll be cool. But yeah, so it's downloading the new version. While it does that, let's take a look at what we've done and see if it's a good place to commit. So we made this find HQ thing, and what is that doing? Oh, it thinks that run HQ has changed because we rearranged a few things, but that's okay. So now we can, oh, did I really change all of that? Oh, this is the landscaper function, right? Okay, so we've added this landscaper function that does some basic stuff and the HQ thing. I think instead of committing the code as it is, we should probably make it a little bit better first, and then go ahead and commit it. All right, the client is still updating, so we'll check for the lowest elevation thing first. Okay, great. So now what we really want to do is we want to say we want to keep track of which tile is the best. So we can make a new map location here. Best place to build wall. And we don't know what it is yet, and we'll make an int lowest elevation equals, we can just make it sufficiently large. And now, instead of immediately putting dirt anywhere that we find, what we can do is we'll check the elevation. So if the elevation of this tile is too low, I don't remember the elevation function, so I'll look it up in a second, but if it's less, or if it's, wait, lowest elevation should be very high, sorry. If it's less than the lowest elevation, then what we can do is set lowest elevation equal to whatever that function is, and then we can set the best place to build wall equals to tile to check. And then at the end here, we can deposit dirt in that location. So instead of the tile to check, we'll do best place to build wall. So now the best place to build wall is going to be the lowest elevation. Oh, this is supposed to be outside the for loop, sorry. So after we've done this for loop to check all of the locations, we'll deposit dirt in the best place. The last thing is that might be undefined, so we have to just do a quick check. If the best place to build the wall is not null, then we want to do all this stuff. And so that'll happen, like, if it's too far away, if it knows where the HQ is, but it's too far away, or all of the locations are blocked, or something like that, then best place to build wall might still be undefined if none of these worked out. Okay, so now we need to figure out the elevation sensing function. So let's jump back to the docs. And it's probably sense elevation. Yeah, great. Okay, so we're going to want to put that here and here. Sense elevation. And then now we should be checking all the locations. If this location is better than the lowest location we've seen so far, which starts very high, then we'll save that one, and then at the very end, we'll build a wall in that place. So great. Let's run the new client and see if that works. Fine, okay. Client, Battlecode visualizer. Okay, lecture player, Central Lake, run game. Um, interface robot controller cannot be applied to given types. Required, oh yes, we're sensing the elevation at nothing. Amazing. Okay, tile to check. Great. Alright, so now we should see the game progress as before, but we should be building a much more even wall, hopefully. Okay. Oh, I can already see the shading is a little bit different on these low tiles. Alright. Hopefully we get some landscapers soon. Okay, yep, there's one up there. Oh, the miners are too good at building design schools, and we're not building any landscapers. Sad. Alright, well, I guess we need to make the miners build fewer design schools. Oh wait, no, we got one right here. Oh, wow, so many landscapers. Look at that wall. 55 units high. It didn't make a difference, but but now we suspect that if only we could like move around the HQ a little bit more intelligently, then we'd be able to like make some serious progress here. So great. They're now building in the lowest location that they can see. All right, but we do have this problem. Well, we should commit first. But while we're committing, we should worry about this problem where these landscapers are not doing a good job of surrounding the HQ to build the wall. So let's go back to our terminal and commit what we have. So let's check the status. Okay. So what have we added? We've added this find HQ stuff. Moved around that function. We're running the miner still the same way. Oh, and that was the landscaper function, right? Run landscaper, yeah. So this is all the logic we just added about building the wall. Great, and then we have this try dig function. Okay, so let's commit this. And we'll say build, make landscapers build a wall. Okay. So we'll pull just to be sure, okay, and then push our changes. Okay. So while we have been working on master, one of our other teammates, me, has been improving the navigation a little bit. So if we go to the lecture player GitHub /Battlecode /lecture player, what I've done is I've created another branch. And so branches in Git are a really cool and interesting thing, where you can split off a copy of the code at one point, make a bunch of changes on it that don't affect other people, and then merge your copy back in. So right now there's a second branch called nav, which is going to be, so this branch, nav, and it looks like GitHub is not loading, but soon GitHub will load, hopefully. Come on, GitHub. There's a little graphic right here that shows you how different this branch is from master, and it hasn't loaded yet, which is a shame. I guess all being on the same Wi-Fi is a problem. Well, regardless, I'll just spoil it. So nav has a couple of commits. The branch nav has a couple of commits that aren't on the branch master. And so this is great because someone could be making a bunch of improvements to the navigation, and I could be making a bunch of improvements to landscapers, and we can commit even like broken versions of the code and stuff, and it won't affect the other person yet. We won't have to deal with any merge conflicts or anything because we're working on separate branches. Totally separate copies of the code. And we can even see if, well, it's probably not going to load. I can show you locally though. So I have a cool tool called getlol, which shows you things like this. So it's not very pretty, but what this is telling us, this line is saying there's this other branch called nav, which has 2 commits, that's these 2 stars, that diverged from the master branch at this commit. So that's what this line to these 2 stars means. But then there are these other commits on master that we just made, and that's where we're currently looking. So someone over here improved the navigation on this branch, and in the meantime, we've done some landscaper stuff. So what we can do is we can create a pull request to get all those changes back together, and you can see exactly what they are. So often on your team, you'll want to like add a new feature, but you need to be able to test it and stuff like that, right? And so you want to be able to like commit and push like code that doesn't fully work and isn't ready to go into the main version, which is master. And so that's why you would really want to use this branch. Like there are multiple commits on the nav branch where like I made a few changes, they turned out to be bad. I made some other changes, that was a little bit better, and then it was like in a state where it's ready. It's ready to be merged back into the main branch. I like cleaned up all of the stuff that I had changed, and we can see here what the differences are, and the differences are I made this go-to function, which is a little bit smarter than try move, because try move just like tries to move in a random direction, and if it fails, it gives up. So I made a go-to function, which is slightly more intelligent, and we can see what it does down here. So it still takes a direction, but if the first direction doesn't work, it tries a bunch of other directions. I'm going to show you in Sublime because the syntax highlighting is better. So let me, the way that you switch between branches is with git checkout. So that's a new git command. And so we can check out nav, which means switch the nav branch. And so now we're on the nav branch. If I look back at the code, run landscaper is empty again because the nav branch doesn't know anything about the changes we just made, which like sounds like it should be bad, but it's actually really nice because it lets you separate the development of distinct features from each other. And so you can like sort of very easily test one change on one branch, and then when it's ready, merge it back into the rest of the code. But anyways, run landscaper is missing, but instead we have this go-to function that I wrote earlier. And so what this does is instead of just trying a single direction, it's going to try a bunch of directions in order. So first it will try the direction you asked for, and then it'll try that direction but rotated left 1, and then it'll try that direction but rotated right, and then try rotate left 2, rotate right 2. So this will try straight ahead, slightly left, slightly right, all the way left, and then all the way right. We could make it try the like slightly backwards directions, but that's way too high level. So we'll save that for the advanced nav lecture. This right here should be simple enough to get us around any obstacles that aren't like shaped like a cup. So if there's just a wall in the way, it'll go sideways along the wall until it can move forward again. And it should be able to avoid like sort of smaller obstacles that get in the way, as long again as they aren't cup shaped, because then it'll just keep trying to move forward and move sideways, and it'll never make any actual progress. I've also done something which is a really nice Java thing, where I've made another go-to function that takes a different argument. So these are both, so in Python, these would be exactly the same function. It's called goto, and it has one argument. But because Java has types, and the arguments have types, Java considers these two totally distinct functions. This is goto, which takes a direction, and this is goto, which takes a map location. They're totally different functions, so it's okay if we make different definitions for each. And the reason that I did that is, again, for the advanced nav. So it's one thing to just try to move in a direction, and it's another thing to try to get to a location. If you're just trying to move in a direction, you kind of just like don't really care. You just want to go in that direction generally. If you're trying to get to a location, then you can do sort of more complicated path finding where, well, for example, you can like follow a wall until you can make some forward progress. Or you can look ahead towards the location, and if you're about to run into a wall, then you can change course or something like that, and sort of do a more intelligent path to a location instead of just trying to move in a direction. For now, our intelligent pathfinding algorithm is figure out the direction towards where you want to go, and then just try to move in that direction the way that we just talked about. So trying straight ahead, and then the two angles, and then the two sides. But this is what will improve when we do sort of more advanced navigation. But for now, this is really good enough to get us pretty much anywhere on these simple maps because there aren't any really tricky obstacles yet.
Question from Discord?
Yeah.
Are the coordinates 0-based or 1-based?
As in, is the bottom of the map 0, 0?
Yeah.
0 based, probably.
Okay.
I can just check though. Where's the client? This is location 0. Yeah, 0, 0. 0, 0 is the bottom left. Great. Okay, right. So now that we have nav, this is some good stuff, and it's a complete feature. So now it's ready to be merged into the main copy of the bot. Oh, that's not what I wanted to do. The main copy of the bot. Yada yada yada. Okay. So here we are. We're creating this pull request. So this is when the feature is complete, we'll create a pull request that says, hey, I want to pull the changes from nav into master. So we can do this, and we can say beginnings of real navigation, real pathfinding, maybe. Okay, and then we can create this pull request. And then other people on your team can like see what the changes are. Maybe they can leave some comments on it or something. So if you want to do that, you can go look at the files changed for someone else's PR, and then I can add a comment here, which is like usually you want it to be something more helpful, but like just for an example, is this a good function name? You can just leave comments in line like this, and then if you go back to the PR itself, you'll be able to see those comments and act on them. So if it loads. So I've made this comment here, blah blah blah. And since I'm going to ignore myself, I'll just hit resolve. And then what we're going to do is we'll look down here, and it says all checks have failed. That's fine. That just means that there's some background thing running for Battlecode. Because this is a Battlecode repo, there's like an automatic test for it that it's failing, but it doesn't matter because we only care about the code that is robot player. So we'll go ahead and merge this. You won't see that in yours because you don't have this like automatic testing stuff set up, but we'll go ahead and merge nav into master, and then we can delete this branch because we don't need it anymore. We've already merged all the changes in, and if we go back here and we git checkout master, so this is back on the main branch. It does not have the goto function yet, no goto, but if we git pull, we see now those changes have been incorporated, and we have a goto function down here. So that's great. And in fact, I can show you the commit graph again. So whereas before, this navigation branch was just all on its own and it ended, it's now been pulled back into master. Let me make this a little bigger so we can see better. It's been pulled back into master and combined in this merge commit right here. So it split off at this commit and it got merged in this commit. So that's great. Okay. So that's merged in, and now we have slightly better nav for our miners. And we can go ahead and see about improving the landscapers. So what do we want to do with the landscapers? We had this problem where they didn't really get close enough to the HQ, and and only built a wall on one side of it. So one way that we could get around that is, instead of just depositing dirt anytime it's possible to, we could have them sometimes deposit dirt and sometimes move. And so that's actually not too bad now that we have our goTo function. So what we can say in the run landscaper function, or you know what, let's make a new branch because that's good practice. So the other thing that the git checkout command is used for is creating new branches. So right now we're on master again. We have all the most up-to-date changes. So what we want to do is git checkout -b, which creates a new branch, and we'll call it smarter landscapers. So now we're on this branch, smarter landscapers, but we've only made it locally on my computer. So right now GitHub doesn't know about this branch. So if we went over here and looked at the branches again, oh well, it's probably going to be slow, but so it only knows about one branch. But all we need to do is push one time. So if I just tried to git push, then it says everything's up to date because it's not actually attached to GitHub yet. This branch is a totally different branch. What we need to do is git push -u, which sets the upstream, which sets the cloud repo that it's connected to. And origin is the name of GitHub, or it's not the name of GitHub, but it's the name of our remote repository. That just refers to the remote repository. Origin is where it came from, and since we cloned from github.com, origin refers to where we cloned from, which is what we want. And then we want to do the branch that we're currently working on. So again, git push -u sets the upstream, sets where you push and pull from for this branch. We're setting the remote to be origin and the local to be smarter landscapers. So this is going to connect our branch, smarter landscapers, to a branch of a similar name on GitHub. And if we refresh right here, we should see that branch. Yeah, so now it's on GitHub, and now the rest of our team can see progress and stuff like that. Okay, so now we're all set up and good to go. Let's make the landscapers move towards the HQ better. So we'll go in here. And instead of always placing dirt, we're going to want to change our mind sometimes. So let's move this best place to build outside of this part. We'll say find best place to build. And then we can take this if statement out here also. And now we want to only do this sometimes. So if we want to build, then we'll do this. Otherwise, we'll try to move towards the HQ. So one easy way to do that is randomly. So we can just say if math.random is less than, I don't know, 0.4. So 40% of the time, we'll just dutifully build the wall. And then the other 40% will try to move, well, right now it'll move us randomly, but if the HQ is defined, so if this does not equal null, then we want to go to the HQ lock, and then otherwise we'll do try to move randomly. Okay. Otherwise, try to get to the HQ. Okay, so if math.random, build the wall. Okay, and I think we're going to need to import math up here. Import. Actually, I don't remember. I'll just Java math import. I think it's java.util, but I'm not sure. While we wait for this to load, anyone have questions about branches and stuff? I went through that pretty quickly. Okay. So Java lang, it looks like. Okay. Let's just be sure. Anyway, so another thing with branches is that sometimes your branch will get out of date with master. So say you're working on better navigation or something, or you're working on a feature that needed better navigation, but it wasn't ready when you made the branch. So now there's better navigation in master, but you don't have it on your branch because you split off too long ago. There's a way to deal with that, and it's sort of the opposite, or it's sort of a pull in the other direction. Okay, I think this is where I imported from. So for example, if we, get status tells us what we're different. I'll show you that in a second because I want to commit this first. So import java.lang.math, and then that should get us math, but let's see. Okay, great. Well, let's just watch the game because that's exciting. All right, so now we've got some minors, and soon we should have landscapers. Okay, there we go. Oh, fine. All right, so we've got our landscapers moving around the HQ and building a wall. Amazing. Look at that. Wow, our HQ is so well defended, and we flooded some landscapers, but that's okay. We're just building up that wall, and we're going to outlast example function player by so much. Look at this wall. It's 30 units high. Amazing. Wow. And you can see that they've dug dirt from all over the place. But fortunately, the wall is safe. So that's great. That's the kind of change that we want to commit and get into master as soon as possible. So let's do that. We'll go here and we'll say get status, get diff, so we can see what changed. Okay, moved around this application thing a bit so that we could choose not to build the wall sometimes, and then we move towards the HQ otherwise. And the reason that move to or go to HQ has been so successful in building this wall is that our go-to function tries a bunch of different directions. So even when the landscaper is right here right here adjacent to the HQ. It can't get any closer. But when this landscaper tries to move towards the HQ, it sees that this direction is blocked, going forward is blocked. Then it tries to rotate left one, that's blocked. And then it tries to rotate right one, and that's open. So then it'll move here. And so this is great because it gets our landscapers sort of like semi-randomly milling around the HQ. Every time they try to move, they'll like circle it a little bit more. And that gets them to move around now that our nav is so much more intelligent and tries more than just one direction. And we can see this in action if we just go back a step. Oh, whoops. Is it playing or is it paused? I'm confused. Okay, so if we, I can't step forward because my screen is cut off. Well, never mind. So, but yeah, so that's what's happening, and that's why we're able to circle it so well, is that the landscapers are trying to move towards the HQ, and so they're sort of circling around it, and building walls as they go. So that's great. Let's go back to committing changes. All right. So we'll git commit am circle HQ to build a better wall. So now we'll get pull just in case. And branches work just the same as master. So if someone else on my team had been making some changes on the Smarter Landscapers branch and they push those, then when I pull, I'll get those changes. It'll merge automatically or not automatically, depending on if there are conflicts and stuff like that. And it behaves exactly the same. Master is just a convention for like the main branch that everything sort of eventually gets merged back into. But they all behave the same way. So now we'll push these changes. Great, we have some Smarter Landscapers. And now let's check out master. So now we're back on the master branch. Our landscapers are less intelligent, but I want to show you what will happen if we want to get a change that someone else made. So we'll just make some change here. What can we do? We can add some comments to the, we'll add some comments to this function. So we'll say idea HQ broadcasts location on turn 1, all units check for the special code. So that way we can tell the broadcasts apart. So broadcasts, code, and location. And that way we can tell which message is which. And we'll do a in-depth communication lecture soon, possibly tomorrow. But for now, we'll just add that comment of this idea and commit so we can see what happens. So we'll git commit add blockchain or add comms idea. Okay, and so now if we look at the state of our branches here, we're going to have one commit on master and one commit on Smarter Landscapers that aren't synced at all. So if we want to get checkout back to Smarter Landscapers, if for some reason we really want the changes that are on master right now, what we have to do to get them is just git merge master. And so what this will do is it will pull it'll merge all of the commits on master into the current branch. And we just have to write a commit message because this creates a new commit. And so now, if we look here, we should have that comment that we just made. So that's great. We've gotten the updates that the rest of the team has made on master while we've been improving the landscapers. In this case, it was like not an important change, but lots of stuff will be going on, and maybe if someone else had been working on a different branch that needed better nav, and then nav got merged into master, then you would want to merge master back into that other branch so that you could use the new nav and stuff like that. But that's really what branches are for, and they can be really powerful if you use them sort of in the way that I've been demonstrating, where different people can work on different features in different branches, so that during the like development process, while you're writing things that are like not fully finished yet, you can test and commit stuff without breaking things for other people. And then when it's ready, like our smarter landscapers, we can make another PR to put the better landscaper code now into master, and that'll probably be a good stopping point for today. So yeah, we'll pull request our smarter landscapers in, and then we can do communications and more navigation, debugging, stuff like that in a later lecture. Does anyone have any questions about anything today, or like requests, or what if you did X, would that make it unhappy, or something like that? All right, cool. Well, thanks for coming, and I'll see you tomorrow. And as always, if you need help debugging, come down and I'll help. Okay.
I tried to update the Gradle or Gradle or
Bye, Twitch.